Okay, this first unlock the problem is the same one that you saw in your interactive lesson, but I want to go over it again because while they explained everything fully, there's a couple of things they didn't go into very deep, and I want to make sure you understand them. So here's our unlock the problem. First, I'm going to read the problem. It says the school assembly room has 10 rows of chairs with 20 chairs in each row. If the third grade classes fill 3 rows of chairs, how many third graders are at the assembly? Okay, that was a lot, so I'm going to read it one more time to make sure I understand what the question is saying. It says the school assembly room has 10 rows of chairs with 20 chairs in each row. 20 chairs in each row is important to know. If the third grade classes fill 3 rows of chairs, how many third graders are at the assembly? So that's what it wants me to know. So right here it says, what do I need to find? I need to find how many third graders are at the assembly. Here you go. That makes it a little easier to see. How many third graders are at the assembly is what I'm looking to find out. So what information am I given? Well, there are blank chairs in each row. Right here, it says there are 20 chairs in each row. The third graders fill how many of those rows? They fill 3. 3 rows of chairs. It says so right here. Okay? Plan. So what is my strategy? The distributive property tells me that I can the factor of 20 to multiply. What can I do? I can split it up. I can divide it. So I can split up the factor of 20 to multiply. So if I split 20, it's the same as saying 10 plus 10 equals 20. Here's the part that I wanted you guys to definitely understand whenever we're looking at this diagram. This is an interesting way to do multiplication, and we'll be able to use it again later with different numbers besides just 10. So I want to make sure that you understand this part. It says to solve, draw a diagram. Finish the shading to show 3 rows of 20 chairs. All right, so I have 3 rows. That's 1, 2, 3 rows. And right here, there's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 chairs. But I need 3 rows of 20 chairs. So I'm going to add 10 more, and it's still the same 3 rows. So here's how they got 30. They went 3 times 10, so they multiplied here. 3 times 10 equals 30. And then I can do the same thing on this side. 3 times 10 equals 30. And then this plus sign tells me that I need to add everybody together. Okay? So that's a plus sign. I can use the sum of the products of the smaller rectangles to find how many third graders are at the assembly. So I can use the sum, that's this one, or sorry, the sum of the products. This is the product, and this is a product, and now I need to find the sum. So 3 times 10 is 30, and 3 times 10 is 30. That's these two numbers. And then I can find the sum of these two products. So I'm going to write 30 plus 30. What's 30 plus 30? Well, I can count up. So 30, 40, 50, 60. I just added 30 that way. Or I can say, okay, 3 plus 3 is 6, and then I just move my 0 over. Either way, my answer is 60. So then I can say, okay, now I know that 30 plus 30 is 60, and doing this right here, this part, is the same as saying 3 times 20 equals 60. So there are 60 third graders at the assembly. This is unlocking the problem, the first one on your work today. I would like you to please do this on ClassKick so that I know you understand it. And then answer this question at the bottom. Explain how breaking apart the factor 20 makes finding the product easier. So we broke apart the factor 20 right here. We broke apart the 20 into 10 plus 10. How does doing this make it easier to find your answer? So you need to answer this question at the bottom of the page, please. Head to the next page once you're finished with this question, and we're going to do one more problem together.